So whenever we have a memory about some experience, it turns out that there are probably a lot of different systems in the brain that are being activated. We sometimes, as scientists, we sometimes talk about memory systems, but I sort of think that that's a misnomer because if you think about what memory is, it's really plasticity in the nervous system. It's the ability of neurons in the brain to change. And neurons in every part of the brain that have ever been looked at have this capability of changing, of becoming plastic when their experiences change. Now, from the point of view of a neuron, an experience is the arrival of neurotransmitter being released by another neuron. So what that does is it changes the way that neuron responds. And across many such events like that in the brain, a memory is formed, or multiple memories are formed. So it's really inappropriate to talk about memory systems because almost every system in the brain forms memories. So what we like to think about instead, or the way I like to think about it, is that memory is a feature of neurons rather than a function of brain systems. So as information goes through a brain system, if that information is significant, it will form a lasting trace as a result of the release of the transmitter and the other things that are going on at that same time. Will form a trace, a connection between the active neurons, and that will stay in the brain in the form of what we then experience as memory later. Now, let's take a situation where you're driving down the road and you have an accident. You hit your head on the steering wheel and you hit it really hard and the horn gets stuck on. And so you hear this loud, annoying noise while you're bleeding in pain. It's really awful and terrible. And then a few days later, you hear the sound of a horn. So that sound will go to various parts of your brain simultaneously. When it goes to a part of the brain called the hippocampus, it will remind you of the situation that you were in, that you were driving, that you had an accident, that you were with John and Peg. But you won't know, it won't have the emotional impact unless it also goes to a different part of the brain called the amygdala, which instead of reminding you of the details of the event, will trigger emotional responses in your brain and body, and the ones in the body will feed back to the brain. And all of that activity in the brain will give rise to what we call the emotion. So back to the fear example, the sound of the horn goes to one part of the brain, the amygdala, and gives rise to the emotional response, and to the other part of the brain, the hippocampus, and gives rise to the cognitive representation. So we call the hippocampal memory a memory about the emotion, whereas the amygdala memory we call the emotional memory itself. Now, these two things happen simultaneously. The amygdala memory is triggered unconsciously. You don't have to be aware of the stimulus in order for that to be triggered. Hippocampal memory is probably triggered unconsciously as well, but you become aware of the memory when it's triggered because of but that's what a hippocampal memory does, is it creates a representation in conscious experience. But that conscious representation now is going to be amplified by the emotional arousal that's taking place, which is going to create a new emotional memory, or a new memory about emotion that's going to have that kind of emotional stamp on it. So it's the interaction between cognitive systems and emotion systems in the brain that create what's called sometimes flashbulb memories, which are very vivid, strong memories of a particular experience. Everyone my age remembers the assassination of John Kennedy in the 60s. We remember where we were, what we were doing, and all of those gory details. Now, it used to be thought that these flashbulb memories were more accurate than other memories, but new research by Liz Phelps, my colleague at NYU, and other researchers who study humans have shown that these flashbulb memories are not more accurate, they're just more vivid. So the accuracy is kind of suspect, and one of the consequences, or one of the implications of that is that memories are constructed or reconstructed when they're retrieved. And at that point of retrieval, the memory has the opportunity to be changed. And that's one of the main topics we've been working on lately, is how memory is changed when it's retrieved. So a good example of the way memory changes during the retrieval process is a situation where someone goes to court to testify about a crime that they witnessed. And on the day of the crime, they gave their summary of what happened to the police. So there's a police record, at the time. And then when they go into the court, they talk about something completely different, which it turns out happens to match what they read about in the newspaper. And so when they read the newspaper, what they did was they updated their memory about the experience. And then in the future, when you retrieve that memory, it's hard to distinguish, what actually happened and what you've incorporated since through other kinds of experiences. And this is now a well-known phenomenon that each time a memory is taken out, the opportunity is there for it to be changed. Now, normally this is an updating process, and it's a useful thing. If you meet somebody at a party and say, that's a nice guy, but then you find out he's an axe murderer or something like that, you have to immediately change your memory of that person, so you've updated it. But in the case, there are other ways that memory gets updated as well, which is that, let's go back to the example of fear conditioning in the rats. So we condition a rat to be afraid of the tone. So the next day he hears the tone and he freezes, because that's how rats express their fear of a stimulus. But if immediately after presenting that tone, we give the rat a certain kind of drug, which I'll explain later, and we test the rat the next day, the memory is no longer present, or at least can't be accessed. So what's going on? Well, it's been known for a long time that memory formation or memory consolidation requires the synthesis of new proteins in the parts of the brain that are forming the memory. So other researchers discovered then that memory, that if you block protein synthesis after retrieval, you can also disrupt the stability of the memory later. But that idea kind of got lost in the late 60s and didn't stick around. What stuck around was the idea that memories are consolidated, and once they're consolidated, each time you take it out, you take out that same trace over and over again. So the new research, which my lab helped sort of rejuvenate in the year 2000, was about manipulating the memory after the rat experiences the retrieval process. So we give the rat the tone, and then we block protein synthesis after retrieval rather than after learning. And when we do that, again, the memory is eliminated just as well after retrieval as it is as it's prevented from being acquired after learning if you block protein synthesis. So the unique feature of our experiment was we were able to do this in the side of the brain where the memory is being formed and stored, which in the case of fear conditioning memory is the amygdala. So because we had done all the basic work of figuring out those circuits, we could go in and put a tiny amount of a protein synthesis inhibitor in the amygdala. And that's important because you can also do this experiment by giving the protein synthesis inhibitor systemically to the whole body. Like if you take a pill, that goes into your body and reaches your brain and does all the stuff, but it's going everywhere. And that's why many drugs have side effects. So if you take an anti-anxiety drug, it not only relieves anxiety, but it makes you sleepy, might alter your sex drive, blah, blah, blah. So what we're doing here is avoiding one of the bad consequences of protein synthesis inhibitors, which is it makes you nauseous and sick and so forth if you take it systemically. And it is pretty toxic, so you would never give a drug like that to a human. This is only something you can do in an animal experiment. So the protein synthesis inhibitor in our studies, though, is put directly in the amygdala, and we avoid all those side effects and negative consequences, since it's a tiny amount and it doesn't affect the rest of the body. So when we do that, the rats the next day don't freeze to the tone. They don't remember that the tone is now dangerous. So this has triggered a whole wave of research now on the possibility of using this as a treatment for post-traumatic stress disorder, because theoretically we can have the people come in, remember their trauma, give them a pill, and the next time the cues about the trauma come along, they won't have the emotional response to it. Well, when I was a kid, I was really afraid of snakes. I grew up in Louisiana, where there are tons of really awful snakes called water moccasins. And we used to go water skiing all the time, and every water skiing spot has this legend of the person who falls in the water and says, oh, I'm trapped in some barbed wire or something down here, and they pull him out and he's covered with tons of baby water moccasins just sucking away on him. So I was a really good water skier because I learned to ski without getting wet, so I would stand up stand on the pier, and the boat would take off and just jump in on the skis and ski around, and then just ski back up on the land. So, the way I acquired this fear of snakes, I think, is we went crawfishing once at this old bayou, and it was a hot afternoon, and the bayou had I remember this very vividly. This is my flashbulb memory. Who knows if it's accurate, but it's very vivid. So it has the sloping side of the bank of the bayou, and there were, like, it seems, thousands of snakes on both sides, just kind of basking in the sun, and it just formed a really terrifying, vivid memory. But I don't really worry about snakes anymore. When I was younger, if I turned to a picture of a snake in a magazine, it would freak me out, but it doesn't really bother me anymore.